Hi everyone, my name's Sarah Barber. I'm the Programme Leader Wind Energy at the Eastern Switzerland University of Applied Sciences, and I'm founder and president of the Swiss Wind Energy R&D Network. Today I want to talk to you about the inclusive and sustainable digitalisation of wind energy, in particular about some of the challenges and innovative solutions for a successful digital transformation. So today I'm first going to talk about myself and my work, and then I'll introduce the topic of digitalisation of wind energy. I'll talk about some of the challenges related to digitalisation of wind energy, and then I'll present you with some examples of solutions that we're working on in my team. So first of all, a project called AeroSense, then the We Do Wind ecosystem, and then biomaterials for rotor blades. So just about myself, if we read from the bottom to the top, I've got a degree in engineering from the University of Cambridge and MIT. I did a PhD in aerodynamics at the University of Sheffield in the UK. I then moved to Switzerland and changed to wind energy, where I had a position as a postdoc and a lecturer at ETH Zurich before I moved to the industry. I worked as a wind energy expert at the utility BKW, and then I worked as Chief Technology Officer at a startup called Agile Wind Power. Then I moved to Germany and was a group manager in field measurements and load measurements at Fraunhofer Institute for Wind Energy in Bremerhaven. I was also a lecturer in wind energy at the university there. In 2017, I moved back to Switzerland, where I started my two companies, Windspire and Mindspire. And I also started working as a lecturer at the universities of Kassel, Oldenburg and St. Gallen. And since 2018, I've been leading the wind energy program at my university, which is known as OST in a short form. And I also founded the Swiss Wind Energy R&D Network. So that's about me. What about my university, OST? Well, if you look at this map, you'll see that it's some of Europe, Switzerland in the middle here. Zurich is here, so in the northern part of Switzerland, you can see Lake Zurich here. Zurich is at the top. My university, Ost, is actually in a town called Rapperswil at the bottom of the lake. And we've got a nice campus here on the lake, which is very nice to work at. And just quickly about the network. So the Swiss Wind Energy R&D Network was founded by me basically with the goal of bundling Swiss R&D wind energy capabilities for the global wind energy market. There's many innovative Swiss small companies and startups who are developing products and solutions for the global market. There are also lots of research groups, and the idea is to just bring everybody together and bring innovation to the international wind energy market. So we look at R&D, coordinating and writing proposals. We do some teaching, so we have some wind energy courses and student projects, and we also have some exchanges and events. You can find out more at wedowind.ch. And so let's move on to the topic of digitalization of wind energy. So the first question that I'd like to ask is, what is digitalization? There are many definitions. This is just one. So this definition I like. It's the use of digital technologies to change a business model and provide new revenue and value-producing opportunities. It's the process of moving to a digital business. And so it's actually taking data and doing something useful with it. This illustration from Anna Maria Semperviva at the Danish Technical University is also a good way of showing that. So on the left, we have what we call digitization, and that's converting information into digital signals. And we have this whole process that we have to go to in order to get to digitalization, which is then actually turning this information into new products, processes, and business models. So why is digitalization important in wind energy? Well, the costs of measurement technology are going down, and also the accessibility of measurement technology is going up. Also, the costs of data storage are going down, and the accessibility of cloud solutions is increasing. The cost of computing are reducing, and the accessibility of data science is increasing. So that's on one side, but on the other side, there's an increasing pressure on companies and managers to make decisions, quick decisions, and also they are getting much more access to automated solutions. There's also a large, high pressure for companies to maintain their competitive advantage. So there's an increasing pressure to differentiate, and there's also high demands of customers. All this basically means that there's increasing reliance in the business upon data and data exploitation to maintain competitive advantage. So what does the wind energy think about digitalisation? Well, the IEA Wind Task 43, a new wind task on the topic of wind energy digitalisation, involves more than 200 people from industry and research actively working on the mission to help bring about a revolution in the way the wind energy industry uses technology, which I'm a part of as well. And as part of this wind task, 30 or more than 30 wind energy professionals were interviewed, and then we did a survey about the main challenges of digitalisation. You can find more about it in this poster here from the recent Wind Europe Technology Workshop. And the results basically showed that these three topics are the most important topics. First of all, data accessibility. Second of all, culture and change management. And thirdly, knowledge sharing and standardization, standardized communication. And then we, as OST, actually in collaboration with IEA Wind Task 43, we carried out 30 more interviews on different people about what are your main barriers to data sharing. And the results basically showed that the top barriers were, first of all, complex rules and structures within organizations, lack of standards for data and data descriptions, a lack of effective incentivized collaboration platform, and a fear of losing competitive advantage. And so now I'd like to ask you a question. What are your main concerns about digitalisation? So maybe you want to just pause the video to discuss it in groups, or if you're by yourself, just to make a few notes and then carry on with the presentation. So I'm just going to carry on now. I'm going to tell you about my top 3 challenges. So the ones that I've identified through my work in IEA Wind Task 43, and also through my projects, what I think the top challenges of the industry are. So number 1 is data and knowledge sharing. Number 2 is inclusion and collaboration. Number 3 is sustainability. And I'm going to talk about these 3 in more detail. So data and knowledge sharing. What are actually the problems? Well, first of all, data is not always accessible or findable. Quite often it has a poor quality. It often doesn't have any understandable metadata. The structures of the data and the schemas vary, and a lot of time and effort is needed to clean and prepare the data. And so what are some possible solutions? Well, to these first 3 problems about the data, accessibility, quality, and metadata, one thing to do is to require that all data is fair. And fair means findable, accessible, interoperable, and reusable. We could publish and communicate guidelines or rules to help people do this. To solve the 4th problem about data structures and schemas, I think the industry needs to be brought together to agree upon some definitions together. And then for the final problem about cleaning and preparing data, I think there needs to be some sort of platform where standards and algorithms for this data preparation step are actually shared to avoid that everybody reinvents the wheel for this part. This doesn't actually mean that you give away your competitive advantage, because it actually means that you can spend more time working on the things that are important for your competitive advantage. And I really think there's a lot that can be done to share solutions for the data cleaning and preparing. So that's data and knowledge sharing. Moving on to the second point, inclusion and collaboration. So some of the problems are that organizations need to think and manage themselves in new ways. There are also new ways of knowledge sharing and collaboration needed in general across the whole value chain. And also people need to develop new ways of working and new skills. So some of the solutions to the first problem, it really needs to be understood by the whole community that people and communication are at the centre of a successful digital transformation. The solution to the second problem, we need to develop a new type of data sharing and collaboration platform to allow companies to actually control access. So they can give access to things that they want to give access to, but not to other things. And the advantages of open innovation needs to be made more clear. And then for the third problem, a solution is to improve diversity, equity, and inclusion, which I'd like to talk about next on the following slides. So why is diversity, equity, and inclusion important for digitalisation? Well, equality is the basis of a fair society. People really work better together when they're happy and feel accepted. And diverse teams are more productive and good for business. This has been shown in many studies, which I won't go into now. And really important for me, inaction weakens already underrepresented groups, which I'll show on the next slide. So even by not actively doing something, you are contributing to less equality and diversity. It's really not a topic that can be put to one side and just left to the diversity experts. I really do believe that every one of us can contribute to improving diversity, equity, and inclusion. For example, you can make more effort during recruiting, you can develop recruiting strategies, you can talk openly about the topic in your team, you can actively support underrepresented groups by role model events, mentoring discussions, etc. So I want to show you what I mean about inaction weakening underrepresented groups. So basically, underrepresentation, let's take the example of few women in technical jobs. If you have few women working in technical jobs, it basically leads to that being the case if you don't do anything proactive. So people are discriminated against all the time subconsciously. So, for example, girls get told not to be bossy. They get compliments for their looks. Boys get praised for being strong and clever. They get given toys that improve coordination. It's not really surprising that girls and boys develop differently. But also for adults, advertising makes women feel like they should be at home cooking and cleaning. There are a few male role models in our society at the moment who you could call chauvinist pigs. No names. Also, things happen like black lawyers getting mistaken for defendants just because they're black. And so what happens to many of this behaviour is not really intentional. It kind of just happens. And the thing is that the desire to belong or to please is a fundamental human need, which basically means that people start behaving as expected because they want to fit in and they want to please. That means that certain skills which get promoted in certain groups get further developed, and even genes can get activated. That's the topic of epigenetics, if you're interested. But this means that then career choices get based on skills and expectations, and this only then leads to strengthen these prejudices or stereotypes, and then it kind of goes around in circles. You have an all-white male management team. It's very difficult for them to understand what to do in order to get more women in the first place, so it kind of feeds on itself. We want to kind of stop this. And so this is a topic which I'm very passionate about, which you can talk to me more about if you want. But then the third topic which I want to talk about is sustainability. And the problem here is basically, how do we digitalise the economy in a long-lasting, green and organic way? So some ways to do this are focusing on long-term solutions and processes rather than on quick fixes. So an example would be if you're generating, let's say, a digital twin solution, we'll talk about that later, rather than just solving it for your project, maybe think about how can I develop a generalized schema or code or script that lots of people can use. It also means building up staff skills and improving their satisfaction on the long term. The second possible solution is to develop circular economy models for key wind turbine components such as blades and generators. But the third point is also really important, and that's actually to develop policy and regulatory frameworks that actually allow businesses to use these circular economy models and innovate productively. So let me tell you a bit about what we do at OST. So we focus on the sustainable and inclusive wind energy digitalisation. we have some different projects. So one of them is called AeroSense, which I'll talk about in a minute. Another project is performance prediction through machine learning. Another project is looking at biomaterials for rotor blades, which I'll also talk about in a minute. Another project is building up this Swiss wind energy R&D network, which I've already told you about. Another one is the We Do Wind ecosystem, which is also one of the 3 examples I'm going to give in a minute. And as well as this, we are developing a new Swiss wind atlas using automated data fusion and assimilation. We are doing some aerodynamic optimization of airborne wind energy systems with a company in Switzerland. And we're developing decision tools for choosing the most optimal wind model in complex terrain. And that includes computational fluid dynamics simulations using the lattice-Boltzmann method. So now I'm going to go into my 3 examples. The first one is AeroSense, the second one is We Do Wind, and the third one is biomaterials. So what we want to do with AeroSense, it's about wind energy monitoring. So we're developing a first ever MEMS-based surface pressure and acoustic smart measurement system for wind turbine rotor blades. So MEMS sensors are the very cheap, slightly less accurate type of sensor that you find in your mobile phone. And the measurement system is a very thin film, well, about 3 or 4 millimeters, like a sleeve, which fits over the blade, and it's entirely independent. So we don't have to make any holes in the blade. We don't have to have any wire connections. It sends all the data into the cloud. And AeroSense is a 3-year R&D project funded by the Swiss Bridge Discovery Program. And it's been carried out by my university, Ost, and also ETH Zurich. It started in May 2020. So we're just about halfway through the project. And as I said, the sort of requirements of the measurement system are that it's thin and non-intrusive, that it's robust, modular, low power, self-sustaining, wirelessly transmitting, and importantly as well, it's easy to install and remove. So customers should be able to just take it, stick it on, measure, take it off, put it somewhere else without much effort or damaging the blade. So here are the use cases. On the left-hand side, we see that reducing the capex. So that's the investment costs. So that's all aimed at, this part is all aimed at improving design tools, improving the performance of the blades, which would be done by the manufacturer of the wind turbine. On the right-hand side, the second customer group is basically reducing OPEX, which are the operating costs. And so this would be used then by the owner operators who would use the measurement system to identify damage, to optimize suboptimal conditions, and therefore the controller, reduce the number of expensive condition monitoring measurements needed, also work out some predictive maintenance strategies, and ultimately enabling wind turbine monitoring on a completely new scale, mainly because it's affordable. And so this is a quick overview of the system. We have 3 subsystems. On the left, you see the sensor node system. So this is the sleeve, which contains all these different pressure, acoustic, and acceleration sensors. It has onboard data processing and transfer systems, a battery, and an energy harvesting system. It's all embedded into one system in a sleeve, and the data is then sent to a base station at the bottom of the wind turbine via Bluetooth, which has a data gateway, and this then sends all the data into the cloud where we have a digital twin running, and on the digital twin we're, as well as running just standard analysis, filtering, understanding what's happening to the 3D aeroacoustics of the blade. We have a number of different machine learning systems in there. So we want to, for example, classify different types of leading edge erosion or structural damage. Just a few more details. I won't go into everything, but here's a picture of the previous version. We've made it thinner now, but this is kind of what the housing looks like, installed on a blade in a wind tunnel. This is just a test that we did on the Bluetooth of the base station. And then this overview is basically showing very briefly what the digital twin is doing. So it's taking the data on the left, it's visualizing it, analyzing it. It's got some machine learning modules in there. And on the right, we have the data, the storage, part. So that's basically an overview of the AeroSense system. And then moving on to the We Do Wind ecosystem. So in this project, we want to bring together people, data, algorithms, and apps. It's a centralized ecosystem for accelerating innovation and learning through inclusive knowledge sharing based around real wind energy industry challenges. And we're doing this in collaboration with a company in the US called Stacker Group. This is basically how it works. So it's centralized around challenges set by the industry. On the left, we have the people, the data, the algorithms, and the apps. The people are giving their knowledge and experience in, and companies or organizations can post challenges which then get solved by this combination of things here. There's some other things that we do as well. So we combine the challenges with smaller requests from people, but also then events, workshops, webinars, and maybe also lectures. This basically allows inclusive knowledge sharing. That means inclusive basically means that everybody gets access and everybody can take part if they're interested. And we also can have workshops and events for underrepresented groups like students from countries that have slightly less access to the industry, or, for example, women in technical jobs. And then this basically results in more innovation, more learning. That could be new collaborations, new businesses, new ideas, personal connections, even recruiting, and student projects. We have also a vision to turn this later into an innovation marketplace, which basically means we develop some standardized environment so that companies can easily come and see these results, these algorithms, these apps, and easily evaluate and test them and buy them or invest in them. But that's a future plan. So an example of how you might use the platform or the ecosystem. So an owner-operator might set a challenge. How can we improve our workflow for fault prediction using this data set? And then the community will suggest some different solutions. They will post their workflows with data, code, descriptions in private or in public spaces, depending on what the what the company wants. Or maybe the owner-operator will even want to have a contest. And a contest is more strict. It's got prize money. It's got predefined evaluation criteria. And then the community may submit by the deadline, and then the results get evaluated. Maybe a researcher is looking for data for a certain model training or whatever they want to use it for, and they can post a request, and then the community will answer, maybe send some links or discuss a private collaboration. Or maybe the researcher will want to showcase their solution in their portfolio. This might then result in requests for further collaborations. So this is kind of what it looks like. On the left, we have the overview page, which shows all the different spaces. So we have different spaces for different topics. I'll get back to that in a minute. And then we have, this is an example of one page of the main page of one space. So you see different posts. If you click on this challenge, it kind of looks like this. So it's just a description of what the company wants you to do. And you can post then responses. And so you can see here all the different solutions are being summarized here on the right. An example solution, these are just two examples. So someone here has written a description, has also inserted a video with their code and a link to their code. Here on the right, somebody has just uploaded a presentation where they're explaining what they've done. And these are the 6 spaces which are currently actively running. So we have a challenge set by the Portuguese company EDP. We have a space for the members of the Swiss Wind Energy R&D Network. We have an IEA Wind Task 43 space where we have a challenge about common metadata and schema. We have a Wind Resource Assessment Decision Tool space where we have a challenge about decision tools for the optimal choice of wind resource assessment. We have the WindG space, so this is a company in Switzerland who has set a fault detection challenge as well. And then we have a diversity in wind energy science space where we're actually trying to motivate the community to tell us what they want and how they would like to improve diversity in wind energy science. And then the third example of a project is the biomaterials project. So as the first multi-megawatt wind turbines start to reach the end of their lives and need to be dismantled, recycling solutions are becoming more and more important. Obviously, the blades are a critical and costly component of a wind turbine system. They can be 100 meters long, made mainly of glass fiber composites as well as carbon fiber. And according to Wind Europe, okay, this is a bit old, but 35,000 tons of composite waste was expected in 2020. This is showing the age of installed wind turbines in the top 4 wind energy countries in Europe and their age. So the different colours are showing how old they are. You can see red means old and blue means new, so 5 years old. You can see this, especially in Denmark, you have lots of wind turbines coming up to 15 to 20 years old, and that's these yellow and orange and red patches are just going to be increasing over the next years. There's a landfill ban in many countries, and also current recycling solutions are either technically challenging, expensive, and or have high CO2 emissions, which is not great. And so some research has gone into alternative materials to make them easier to recycle, for example, using biomaterials such as hemp and flax, for example, this Green to Green project. But no suitable solutions really been found in terms of performance up to now. So we basically wanted to investigate this topic and test the application of biomaterials for manufacturing wind turbine blades on a small-scale wind turbine. We chose flax due to its high Young's modulus to density ratio. And we spent quite a lot of time trying to manufacture some nice samples. So we tried with different resins, and eventually we found a good combination of flax fibers with the commercial bioresin Cycamine 8100. And we built some samples, we tested them in a tensile testing machine. We built 4 1-meter long blades, we attached strain gauges to them and made some strain measurements. We then installed 3 of them. One of them was just a spare on a 1 kilowatt wind turbine, and it's basically been operating for the last 8 months. And the first inspections basically show that it hasn't changed its performance since the beginning, and it seems to be okay. But obviously, we need to do much more work on that. So just to conclude, the digitalisation of wind energy is in full swing. There are many potential benefits and opportunities for wind energy. Also many challenges. My 3 top challenges from my experience are basically data and knowledge sharing, inclusion and collaboration, and sustainability. 3 examples of solutions being worked on by me and my team are AeroSense. I forgot to mention actually, with AeroSense, one of the things we're doing is we're developing open data sets and also generalized digital twin architecture. I think I mentioned that point in the sustainability point earlier. The second one is the We Do Wind ecosystem, where we're trying to accelerate innovation and learning through inclusive knowledge sharing based around real wind energy industry challenges. And then the third one is the biomaterials for wind turbine blades, trying to improve circularity and offering alternatives for expensive and energy-intensive recycling solutions. And then finally, I'd just like to ask you, how could you be encouraged to share more data and knowledge? What would you need? What would you like? So maybe you can discuss that amongst yourselves now and press pause. Or if you're by yourself, maybe just have a think and write it down. And then finally, I'd just like to thank you for listening. You can join us on our journey by joining the Swiss Wind Energy R&D Network for free here. You can also see more about our different We Do Wind spaces here. Thank you for listening. Bye.